Let's take a closer look at arithmetic sequences, and we're addressing California State Standard 22. Students need to be able to find the general term and the sums of arithmetic series, and then we'll pick up geometric series in a future lesson. So our objective for today is to find a formula that describes the nth term for an arithmetic sequence, and then to find specified terms of the arithmetic sequences themselves. Now, there's a formula you should memorize, so here it is. Without this formula, you will not do well in this chapter at all, and this formula, you need to remember, only applies to arithmetic sequences. If you're looking to find the nth term of an arithmetic sequence, use this formula. T sub n, or the nth term, is equal to T sub 1, or the first term, plus the quantity n, the nth term, or the number of the term, minus 1 times d, the common difference. So again, make sure you memorize that formula, and then we need to try to apply it. As we do so, let's find the formula for the nth term of this infinite sequence, 5, 8, 11, 14. So as we look at this, let's refer to our formula for arithmetic sequences, and let's delineate what everything is. So T sub 1 refers to the first term, so let's just list that. That's 5. Let's look at D, the common difference. What do I add to 5 to get 8? And is there a same number I add to 8 to get 11? Is that the same difference that I add to 11 to get 14? And yes, that is. It's 3. To verify it, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3. So 3 is D, the common difference. And in this case, we're looking for the nth term. So n, the variable n, stays n. All we can do here is distribute out. We get 3n minus 3 plus 5. And 5 minus 3 is 2. So the nth term for this arithmetic sequence, or the formula that describes it, T sub n, the nth term, is 3 times n plus 2. 3n plus 2. By the way, you can see that common difference here is represented in the 3 times n. And the 2 is where we're starting. If n is term 1, 3 times 1 is 3, plus 2 is 5. That's the first number we're starting at. Alright, let's do this. Let's put this formula to use in a different way. Let's find the 15th term of this sequence, 4, 9, 14, 19. Now before I do, I know what you're thinking. You're probably thinking, I don't need to memorize the formula to answer this question on the test. All I have to do is I see what the common difference is in my mind. All I have to do is just keep adding 5 until I get out to the 15th term. Well, let me suggest I'm aware of that, and I want to hold you accountable to use the formulas. So I'm not going to ask you for the 15th term on the test. I'm going to ask you for maybe the 1215th term. And by the time you keep adding 5 1,215 times, you will not complete the test on time. However, if you know the formula, it'll still be just as quick, even if it's 2,315 terms or however many terms I ask you for. The formula is just as quick either way. So please, don't look at this example and think you don't need to know the formula. Alright, so we're looking for the 15th term. So everywhere we see n, we're going to replace that with 15. But before we do that, let's find that common difference. And yes, 9 minus 4, 14 minus 9, 19 minus 14 all give us 5. So the common difference is 5. The first term, well, that's easy to figure out. That's 4. Substitute those numbers in the formula, T sub 15. Now we're going to replace all the n's with 15. And if you want to look at an example like this on the test, here's how easy it is. If I asked for the 2,315th, then you replace these 15s with 2,315. And it'll be just as easy. You'll subtract 1 from that, multiply by 5, add 4, and you'll be allowed to use your calculators. So you will need to know the formula, and it will be just as easy. But with these small numbers, 15 minus 1 is 14. 14 times 5 is 70. 70 plus 4 is 74. So if we kept adding 5 to the 5th, 6th, 7th, 8th, 9th, etc., got to the 15th term, the 15th term, T sub 15, would be 74. Alright, let's look at that formula in a slightly different light. Same formula again, but we're saying the term number itself is 301. The term itself is 301. What term number is that? So we've got 4, 7, 10, 13. We keep adding and adding and adding. Eventually we get the number 301. Now that's going to be pretty small, so again on the test I'm not going to give you something that's small. I'm going to give you something larger, like 3,301. First, let's start out with a common difference. So 7 minus 4, 10 minus 7, 13 minus 10 all give us the same number. So that common difference is 3. The first term, well, that's just a simple. Just look at that. The first term is 4. Should be no excuse not being able to figure out the first term. Now in this case, we replace t sub n with the actual term itself, 301. And we're solving for n to find the term number where the term is 301. So again, if I chose a larger number like 5,301, this would be 5,301. Everything else would be the same, and you've got calculators to help you out. So let's distribute out that 3. So that's 3n minus 3. Let's simplify. 4 minus 3 is 1. Let's get n by itself by undoing addition by 1. Let's subtract. So 300 is 3n. Divide everything in sight by 3. And n is 100. So what we're saying is that the 100th term is 301. I know that takes a little bit of time to keep adding 3. I know you can do that quickly. I know you could do that 100 times. So that's why I'm still not choosing any number that's small on the test. I've seen people write out adding 3 100 times. So it's very important you still have that formula memorized. Okay, this one's a little bit trickier, but it's the same formula. And I'm not getting all the information I need in one equation. The third term of an arithmetic sequence is 8, but the 16th term is 47. Find the 25th term. Well, here's my formula again. T sub n equals the first term, t sub 1, plus the number of terms minus 1 times the common difference. Here's what I know. The third term is 8. T sub 3 is 8. Alright, what I also know is the 16th term, t sub 16, is 47. Two different equations, and yet I'm looking for the 25th term, which is completely different. So what I have is, if I were to substitute these two numbers into my formula, I would have two different equations, and I would get two equations with the same two variables. And if you recall this from chapter 4, we solved systems of simultaneous equations. That's what we get to do here. So let's take the third term equals 8, put that in the formula, and say 8 is equal to the first term plus, that's the third term, so that's 3 minus 1 times d. And if we put in the second piece of information in there, 47 is equal to the first term plus 16, because that 47 is the 16th term, minus 1 times d. Let's simplify each of those two equations. And in doing so, 3 minus 1 is 2, and in the red, 16 minus 1 is 15. We now have two equations, two variables. So what we need to remember is that we solved systems of simultaneous equations using graphing, which we'll not use here. That's not accurate enough. Or we had substitution or linear combination. So let's use the linear combination, which sometimes we also call elimination or the addition method. Let's line up everything that's the same. If you recall, we lined up the constants, lined up the equal signs, lined up the two variables. So I've got my t sub 1's lined up, and I have my d's lined up, equal signs lined up, and my constants lined up. And we subtract. Again, be careful when you subtract. I suggest adding the opposite so we don't make any careless mistakes. And you can see that t sub 1 minus t sub 1 drops out. 15d plus negative 2d is 13d. 47 plus negative 8 is 39. So we have combined these two equations, just like we did in chapter 4, into one equation, one variable. Solve this by dividing both sides by 13. D is 3. Now, we're not quite done yet, because that's d, the common difference. We don't know what t sub 1 is yet. So we can find that by substituting 3 in for d. So let's do that. T sub 1 is 2 times 3 equals 8. Now I'm substituting that into this first equation right here. T sub 1 plus 2d equals 8. I could substitute that number 3 into either one of these equations, the blue equation or the red equation. The blue equation had some smaller numbers, which is why I chose that. So 8 is equal to the first term plus 2d. Replace d with 3. 2 times 3 is 6. To find t sub 1, subtract 6 from both sides, so that's 2. So now that I know the common difference is 3, the first term is 2, let's put that into the formula. The nth term is 2, the first term, plus the number of terms minus 1 times the common difference, which is 3. And what they were asking us to find was the 25th term. So t sub 25 equals 2, the first term, plus 25 terms minus 1 times the common difference, 3. 25 minus 1 is 24. 24 times 3 is 72. 72 plus 2 is 74. So the 25th term of that sequence, of that arithmetic sequence, is 74. All right, next we're looking at something called an arithmetic mean. Now we've been doing this for years because arithmetic mean is another way of saying average. In this case, we're only looking at 2 numbers. So we add the 2 numbers together, divide by 2. To find the arithmetic mean between 7 and 19, therefore, we take 7 plus 19, add them together, take that sum, divided by 2. So 7 plus 19 is 26. And 26 divided by 2 is 13. That's the arithmetic mean. Way too easy, I know. That's when you're only looking for one arithmetic mean between any 2 numbers. So the next place we're going is to insert more than one arithmetic mean between 2 numbers. Insert 3 arithmetic means between 8 and 16. Now, here's my strategy. I suggest we use the formula. I know some of you are looking at this and say, I don't need the formula, I can use the previous formula. You'll say, well, I can find this middle term by averaging 8 and 16, and what I get there, I could use this middle term as the average of those, and this missing term as the average of those. But to get you to get into the spirit of this, which is to use the formula, I'm not going to ask you for an odd number of arithmetic means on the test. I'm going to ask for an even number of arithmetic means so that you will apply the formula. So let's look at the strategy for applying the formula. 8 is the first term. I need to put 3 numbers in between, so that's the first, second, third, fourth. 16 is the 5th term. 8 is the first term, 16 is the 5th term. So let's look at our formula. T sub n, the nth term, equals the first term t sub 1, plus the number of terms minus 1 times the common difference. So in this case, 16 is the 5th term. So t sub n is 16, n is 5. 16 is the 5th term. T sub 1 is the first term, that was 8. Solve the simple equation. 5 minus 1 is 4. Subtract 8 from both sides, 4d equals 8. And solve to find out that d equals 2. And now I know even before we found out the common difference was 2, some of you knew this. This was way too simple. You could solve it in your head, 8 plus 2 plus 2 plus 2 plus 2. But let's just take a look at that for a moment and pretend we didn't see. So 2 is the common difference. 8 plus 2 is 10. 10 plus 2 more is 12. 12 plus 2 more is 14. And then let's check that 14 plus 2 more gives me the 16. And you say, wow, if it's going to be this easy, I don't need the formula. Well, to keep you honest, first of all, remember, I'm not going to ask you for an odd number of terms. And to get you to use the formula, I'm not going to have a common difference as simple as 2. Most likely, I'm going to choose something where the common difference is a fraction. So my recommendation at the beginning of the year was that you have a scientific calculator with a fraction button in case you can't do fractions. All right, so that's our look at using the formula for arithmetic sequence in many different situations, including finding arithmetic means.